In Anvil 146, we had a Marlin 30G pump gun, and in order to get the fore-end metal dynamited apart, we had to sacrifice the fore-end. So it was going to be more than 5 minutes to do it. It wasn't going to fit. That video was forever long anyway. So basically, what we've got to do is take a hunk of walnut and make it fit. Okay, we got to take this hunk of walnut and make it run down on this tube and make it kind of look close enough. So I've been practicing in the run-up to showing you guys this. I've been practicing drilling holes through blocks of wood, because not only do we have to drill this hole through it, it's got to be straight. And it's got to be in the middle of the block. So how do you do that? So we'll do a little bit of this kind of a micro rabbit hole. We'll kind of call it a gopher hole, I guess. And we'll get down there and take a look at how I think we're going to be able to make a cutting tool out of this piece of metal. And we're going to drill some holes and just try to make this 30G look less heinous. Let's go. This tube, all right, we got threads, and we got a piece of pipe, right? And then welded to the end of that, there's an end cap that's going to go over this like this, and that's how I'm going to do it, because it's kind of what it looks like. This end cap is actually out to here. The threads go through. Immaterial for us, but we got an end cap there, and we got an end cap here like this. Guys, if you can't draw it, you can't cut it. All right, if you can't draw it, you cannot make it. You just can't. So I'll tell you, one of the things that I do know is that here to here is 1.10 inches, and I'm only going to work to hundredths in this particular case, just because I got to work to something. All right, so we know that that's the OD of the tube, which means that's got to be the ID of the wood. All right, so the wood is going to be a piece. Are we in over here? Okay, the wood's going to be a piece that's kind of going to look like an elongated football with a hole drilled down the middle of it and a bunch of grooves cut in it at 3/8 of an inch intervals. Right, and we know that there has to be a little slant here at the end, a little slant here at the end, and a little slant here at the end. And those slants are in there, and those are what's going to go up inside the bell ends, and that's how that hole holds this thing on, right? So this tube really isn't 1.1. It's like 1.0957 or something like that. Fine, we're going to make the inside 1.10 inches. I know I'm not working in metric. Sorry, I'm an English guy. We're going to have to get over it. I know that it's got to be, the raw blank is going to be about 7.00 inches. All right? That's going to be the raw blank. So that's going to be the block of wood that we're going to make it out of. No, we're not making this out of pine. Yes, I'm making all my mistakes in 10 cents worth of lumber. All right? We'll make our mistakes on the walnut later. Make your mistakes with cheap materials. Learn how to run a lathe by turning wood in a metal lathe. Because that way if you screw up, you don't bend a spindle, you don't whack a cross light off, you don't screw up tools, and that kind of stuff, right? All right. So when this is all done, here to here is going to really wind up being about 6.5. But we're leaving it a little bit long because I want the option to milk in on it. And then to cut the grooves in this thing, we got to make a tool that's rounded here, has a cutter sticking out, and is rounded here like this, and that'll be in the lathe tool. And as we plunge in, move down 375, plunge in, move down 375, we'll be able to replicate that. But that's later. The big one's going to be, we got to drill a pretty big hole down a pretty long piece of block. And it would be really nice if it followed the center line of the device. So that leads me to, well, why did I break the wood? Because it's a lot easier to make the wood than it is to make the metal part. So we're just not going to do that. We're going to make the wood. It'd be nice if the block was not going around in a lathe like this. It'd be nice if when we do it, it moves. So how are we going to drill a 1.1 inch hole? Well, that leaves me to the next part, which is this bar right here. We're going to take this bar, I'm going to drill a hole through it, and we're going to put a cutter in it. And I'm going to exaggerate the size of this cutter. Screw head, screw, sharp point, nut, nut. So we can back these nuts off and run this cutter in and out the way we want until we get here to be half of 1.1. That center line to outside distance is going to have to be about 0.505 is what that's going to have to be. Are we going to measure it? No. We'll cut and try this. We'll advance this cutter a little bit. We'll bore it in and we'll see whether or not the pipe fits, and we'll go till the pipe fits. I will tell you at the end of all this, there are fancier, higher speed, more accurate ways to do what I'm about to do. And that's great if you've got the time to do all the setups. I'll be through with this. We'll be done filming it. We'll be editing it before it's time to have a beer tonight. So here we go. The final dimensions of our block don't really mean anything. So ask yourself when you make a rifle barrel, do you drill the hole and then turn the outside of the barrel down and be concentric with the hole? Or do you make the outside shape of the barrel and then drill the hole and pray to God that it's in the middle of the outside shape? It's cheaper to do it the second way, but better to do it the first way. So all I'm going to do here is kind of just get a rough center line on this block. I would like to know roughly where the middle is on both sides. Precisely where it doesn't matter, but we're going to drill this hole in from both sides so that any issues are met in the middle. I'll tell you what, I got a vise. Why don't I use it? So we'll just hack off a line here, hack off a line there. Okay, good. As you can see from the sawdust, I've already done this once because I wanted to make sure it was possible. Okay, this is a 7/8 Forstner bit, and I'm just going to kind of get it going here and sort of eyeball it up the middle, and I'm pretty close. Now, why did I select a 5/8 bit, or 7/8 actually, sorry? It's because I know this hole's going to have to be about another 300 thousandths larger in diameter. So I want to get rid of, I'm hogging out the waste in the middle, but I also want it to be big enough that when we feed it across, all of the wood gets taken out and any flaws in how these two holes line up disappear into that. Now, when we do this in walnut, that's going to happen significantly slower. I can hear everybody complaining now about my ersatz drill bit, but it doesn't have to be that good. All it's got to do is go in. Okay, here we go. Yeah, that's Rubas Goldberg, but there we are. So now we got a block of wood. Now, why am I not drilling the walnut right now? Because I got to make sure that the next thing that I'm going to do is going to actually work. So you see, we're a little off center here, a little bit. We're a little high here. We're going to see if it matters. So I got a 5/8 bar here, and we're going to drive it from this end with the chuck. We'll turn it in and clean it up. Drive it from this end with the chuck, and then we're going to put a center on this end, so that this will turn, and this is going to become our cutter. So what we'll do here, we'll prep by filing a flat in this. I just want to make a slight flat in it, because then I can dig out a punch. We're gonna drill a 1/4-inch hole through this thing. We're gonna put the cutter through. And all the cutter's gonna be is a screw. There we go. And what I'm looking for, I may need to go a little bit larger, but what I'm looking for is that to be able to go straight through. Now, we're going to put a nut on the top of this and a nut on the bottom of this. So we didn't want to thread this hole, and the reason why we didn't is because then on a 20 thread per inch screw, I'm stuck with 40,000th of an inch moves because I'd have to come all the way around because we're going to sharpen an edge on this thing. The other thing we're going to do here, let me have that block. So this thing will be fixed in the lathe, right? And we're going to mount this on the lathe. So we need to start here, and then as we move the lathe over, it'll feed over the tool and give us an absolute drive there. So, and then we'll just move the cutter out until we anecdotally get exactly what we want. All right, well, we've got a cutter mounted up inside here. You see the cutter going around. I've got the drive engaged. I'm opening up the hole through the center line of this after we got it all torqued down. When we're done, we should wind up with a hole of consistent thickness mounted all the way through. That's the fit I'm looking for right there. We'll go in with some focus cloth and we'll turn the inside of the tube out. But basically, we're there. And now we're going to go ahead and put this thing up on a jig and spin it and get the outside contour right. I'm well aware of the fact that the rear end of this is jumping around, but this is a checkering mandrel. So when I do this in walnut, I'll turn a bespoke mandrel through the center of this. This is shimmed up with tape in both directions, and trust me, this isn't going anywhere. So what we'll do is turn this round until this device falls through all the way down. So I've ground slightly, I'll slight bull nose into this so that as we start grinding the crown, you know, there'll be a hump to this. And when we do that, the tool will always touch. So for right now, we're just gonna start nipping away at this and just take the corner off of it. Now, if you get bored, you can set this thing up to feed like crazy. So let's go alpha. Let's go alpha right there. Where are we at? There we go. Now we're in. And then let's see. We got to set it up to go the other way. Okay. And this thing should make some chips. I don't want to put too much load on it, but remember now, this is a piece of pine. Pine turns differently than walnut does. But what we're trying to do is just get through the steps, get our kit set up. Then we'll come back and we'll do it in walnut. And actually, I'm going to kick this up to high speed here. Wood likes to be worked at high speed. In fact, some of the RPMs that some of these woodworking tools turn at positively scary. When we get to the end, we'll take a lot deeper cut as we go, because as we start taking the corners off, the cut will be less and less interrupted until we get one complete smooth straight through, right? You do have to remember though to guard the half nut, because if you forget, this thing will crash. I'll shut it off here. And you can see now we're starting to take the corners off. Now we'll go back the other way just as fast, and then we'll take off here and do that. So we're going to take a lot deeper cut this time. This time I'm taking about 30 or 40. If we were machining, we'd take about 10 times. So you see now the corners are a lot bigger. We're taking more off the darker ends here. So let's take off again. Let's go the other way. Let's go high speed, kick in, and this time we'll take about 40 or 50 off. It's quite a cut. I'm taking quite a lot. In fact, if you bring the camera up here, you can watch the cut progress. You see it? So like when we go to cut the finger grooves, that'll be important, because the reason why the wall was painted blue behind it is you get this beautiful background when you're trying to cut. Now, everything's in the way when you're doing it. But, so that is why we painted it. That was the biases I had. Somewhere I got the formula for that. I don't really think it's more oil than it is blue. Okay, now this time I'm just going to leave it running. Kick it out of gear. We'll go back the other way. Come in about 40 or 50. Kick it into gear and go. Okay, we're going to start getting to the point now where we're cutting more than we're not. So in this particular case, we've still got all this dead space. The cutter comes off, jumps, and cuts to here. And this is what I'm trying to not badger the wood. You know, we're blowing spots out of it. It'll be a little bit different when we're doing it in walnut. But here we go. Let's see, go slow, light it up, high speed, come in about 140. Wrong way. Gotta remember to switch the direction of the drive here. I did that. You would think. And here we go. The more of those corners I get rid of, the more greedy I can get coming in. Almost. Now there's a way you can see, if you bring the camera over here, let's switch positions. Is the camera showing that dark line back here? Because this upper line here that appears to be opaque is where we have to go yet. Once it gets down to the solid part, that's where it's solid wood all the way around. I don't know if the shutter's speed or the speed of the lathe is going to let me get away with that. And then we're going to quadruple the speed of this for the final cut, for the nice smooth cut here. We're going to really stand on the spindle speed. And so we're going to cut this back off and then take a look at it. See, now we're getting to the point where most of it is a cut and then there's a little skip. and most of it's a cut, right? So we're going to come up to a lot higher speed here. And we've already reversed. No, we haven't. Okay, here we go. There we go. Okay, we're going to shut down here because I want to change the direction, but I don't want to do it when we're running this fast. So you see now we're almost all the way around, and after the next pass we're probably going to be. Here we go. Dropping out, shutting down, switching directions. Damn it, we're almost there, right? Turn it back on. Pumping in another 40. Then I'm going to get a piece of sandpaper when we're down this fast. I'm going to show you something. Okay, I'm going to get a piece of sandpaper here and show you something. We should be damn near down to the bottom of it. We still got a flat spot there. All right, that one big flat spot would have disqualified this wood for the gun had we chose to do it. Now, in our case, we could just say that this is where the barrel goes, and we could do that, but we're there. Let me get a piece of crocus cloth here and demo something. And we're going to crocus cloth, and we're going to do it this way, because if this thing grabs it, we don't want to get our hands sucked into what's going on here. So let's take it out of gear. Okay. The next thing we would do now that we have it pulled down is we would sand a crown on it. We would take this and we would just make up a paper gauge that as you held it behind it, see here we know it's straight, but if this gauge was bent, right, we could say we need to remove stuff from the end but not from the middle until that touched down, right? All right, last thing we're going to do here. This is just a parting off tool, but I'm going to use it to prove a point here. Okay. I'm going to mount that, walk up, verify that I'm in neutral here, and then I'm going to engage the half nut. Okay. I'm going to take this thing out of gear because I don't want to be turning all those gears in the back. I want this to be real easy to move, all right? So let me get this in a neutral spot here where that'll turn easily, all right? So now, each rotation of this thing is 120 thousandths of an inch. So if I wanted to go 375,000, it'd be one turn of 120, 240, 360, yeah, and then 15. All right, so 316, so watch this. We'll turn this on. We'll plunge in and we'll cut a groove. Come out, we'll go one turn, that's 120, 240, 360, 375. All right. 1, 2, 3, and 15. And this should be pretty damn close. That is how you get the finger loops all the way down. I'll put an indicator on this thing to make sure. But we would do that with a round nose tool. That's the right thickness. And we would wind up with finger grooves that are about the right thickness apart. All right, now I'm not going to verify that these are all exactly 375 apart, but pretty close, right? See, I can make it line up or not line up depending on where I hold it. It just depends on the guy that turned it, right? But there you go. That's how I intend to do it. So that's pretty much it. We did all of this in pine just to make sure we got our setups right and everything. And it still took a hideous amount of time to film it. And we're right back to whether or not this gun probably should have been done or not. It should have been cut up for parts. I've previously asked you guys for your opinions on that, and you're giving them to me, and I really appreciate that. However, I just kind of wanted to show you how I was going to go about doing that. The rest of mounting that's just going to be inletting the anti-rotation pins, getting it all to set down, torque it up, sand it, and be done with it. Okay, so we just want to kind of find sort of the approximate middle of this. And then since I'm going to use a piloted bit, I'm just going to take a punch and set that so that the bit won't walk around on me while I'm trying to find the center. Okay. Now I'm going to choose to drill in and out like this. About halfway through is around half of this bit, so we'll just come in from both sides and we'll just milk it until we get the middle. And just walk up. While I'm doing this, I'm watching these lines and I'm seeing where they cross, so I can feel if the bit's sliding a little bit. So you'll see me maneuvering. All I got to do is kind of get the hole stuck down the center of this, and then we're going to take all of the inequities out in the lathe. But I am steering it, and it's all optical. I'm looking at the line should be appearing to cross through the middle. If I drift this way, this line you can see goes high. So that's what I'm doing and how I'm drilling it freehand. It is raining outside like a cow whizzing on a flat rock. So if you're hearing a lot of broadband, that's just the rain thumping on the ceiling. It rains here in South Carolina. It could happen. There's still time to die. This little bit of mess up out here where the blade chopped it, I'm not worried because this block is about 1/4 of an inch over length, specifically so that all that will wind up on the floor. You don't want to make it too long. cheat. I'm going to cheat the drill bit out. And I'm not holding on to it by much, so I'm not going to ask it to do a lot of work. I'm only holding on to it by about 1/4 of an inch. I'm just going to try to nudge it in. And now we'll come in from the other side. Pretty close. Okay, we'll come in from the other side now. Should be it right there. And that should be it. Man, we should be very close. So now we're going to switch over to a drill bit that's just wrong. All right, some of you are going to go, I should be doing this with a hand brace. I don't really care, but what I want is for this to meet in the middle. And then any hole misalignment we had will be in the middle of this block. Now this bit's bent, but it's going to do what I want it to do. There it is. Now we're up on a face. Okay, now we'll come in from the other side. And we're still undersized for the hole we want. It should be, yeah, we're right in the middle. So this should break out here. And in fact, the reason why I think that bit was slipping a little bit is because the auger on the front has already penetrated. So it's not drawing the drill bit forward. So there we go. Now we've got a hole that's smaller than we need, but most of the waste has been hogged out of the block so that we're not trying to run a really itty-bitty boring bar in here. We can run a boring bar that has a little bit of scope. The mandrel that we turned the pine on was a checkering mandrel, and it wasn't square. And I told you I was going to come back and square this thing off so that when we shim this up now with tape, it will come up straight and the workpiece won't be hula hooping the way it was before. Anyway, I just wanted to show you this before we got going because I've got to break this setup, take this all off, and mount the block on top. We've got the block chucked down on the, this would have been a mill. This was a lathe mill drill, so this thing actually has a milling table on it. And we've got that cutter set so that it's going to take a little bit of walnut out here. We'll fire this up. Put the lathe in advance because the carriage is going to go this way and forward. And then we're going to come down to a much slower feeding speed. And we're just going to see what this sounds like when this comes in. So I'll engage the carriage and you'll see the handle start to move here once all the slop comes out of it. And no, I don't need to go this slow in wood, but if this thing wrecks, I want to have the ability to jump out and not screw up too much of my walnut block here. And it should start cutting here in a couple of seconds. So the cutter is going to emerge, and the hole on this side is a little bit bigger because we were playing around with a couple of things here just to make sure we could actually drill a hole this big in a piece of walnut. But just like with the pine, here it comes. Okay. There's our cutter, and there's the hole we made. We're gonna have to go a little bit bigger. I had brought this cutter down and cut it, and actually made it a little bit shorter because this walnut's a lot harder than a piece of pine, and it had this thing hula hooping, and it's pretty rigid. And it was hula hooping the whole thing. It was sliding, the cross slide in and out up against the take up in the screw here. It's fine. We're drilling a hole through a piece of wood for a fore end on a pump gun. So we've got a block of wood. This is our pine one, and we know we want to shape this kind of like a football. How am I going to do that? Well, the way I'm going to do that is I'm just going to take this. I'm going to take this yardstick here, and I'm going to lock it down. All right, and in between, that's about the size we're looking for, there to there, right? So on those 2 points, I'm just going to prove something here. I'm going to run a pencil line down each one of these. That's about perpendicular to the edges. And then I want to show you something here. We've got to make a cardboard template that's going to allow us to comparison check what we're cutting. And what I would say is that in between these 2 lines, let's swing off a 26-inch arc. 26 there to 26 here, right? And we know we're about right. And we're looking at it there, and it touches in both spots. Hang on. Touches there, touches here. And if we put the pencil there, it's going to do a pretty good job of swinging off a 26-inch arc. Okay? So let's come back in now and let's look at 18. So this is a 26. Let's do an 18. 18 to there. We got to kind of get up in the middle of this here. 18 there to it's going to get it more. Okay, 18 there. So if I did an 18, that's an 18. So let's get way small. Let's do a 10. All right. So the 10's touching the line here, and it's touching the line here. So if we swing off, let's see here. Do I have that even? Nope. There to there. Okay, that's right. So if I do a 10 here like this, so we can see that the closer we're getting, the deeper, this is a 10 here, the deeper this is going. Let me get this thing out of the way. Hang on a minute, because it's going to be a pain in the neck. So I'm looking at the curve I want, and how much meat do I want on that piece of wood here? How much meat do I want on that? Do I want about that much meat? Do I want about that much? I think the 10's a bit much. Just looking at it, I think the 18's about right. And I picked 18 out of the clear blue sky because that was the number that I picked before we started doing any of this. But, all right, 18 to 18, good. So I've got my arc cut. And I'm just going to come in and cut this arc. And I'll show you what we're going to do with this. Cut that back at a reverse angle. Cut that back at a reverse angle. All right, now up against the blue background, I'll show you what I'm talking about. We got this spinning in the lathe, and we put this here. It's pretty obvious we have to remove material at either end until this drops down like this. So let's go up on the lathe and see what that looks like. So you can see that swatch of blue behind that. And what we're going to do is take this, turn this thing around first, and then we're going to make that big old swatch of blue behind it disappear. Woodworking generally likes to run at a slightly higher speed, so I'm going to go ahead and set this lathe up to run at about 1250 RPM. And you'll notice from when I did this in pine that I have trued this mandrel up. You go back and watch the part in pine, you see it skipping all over the place. And I've got every, I mean, it was hula hooping down here. And I went ahead, this was just a mandrel for checkering. And I cleaned it up, put new tape shims in it, and it's now running absolutely concentric, and I'm not worried about. So like we said before in the pine, king of the interrupted cuts, because right now we're only cutting a little bit and we're not cutting a lot. As this goes along, we will go down to where we are not cutting a little bit and cutting a lot. Could we have taken this to a belt sander and sanded these corners off? Yeah, but not nearly as cool. So now we're down to where we're mostly cutting short skip, and pretty soon this thing will be a tube. We're darn near there. See, that's the only flat spot we've got, and this is all the way around. So let's set this up to go forward. And let's drop this in gear and just let it run by itself. The maximum dimension of this piece is going to be about that big around. And that means the maximum dimension will be right there in the center. This still has a little ways to go yet. We've got one more pass to get it down to a cylinder, and then another pass to get it down to its maximum dimension, and then we'll remove everything that is in its maximum dimension from the sides. Get in there with some crocus cloth and sand it out, and that'll look pretty good. We're darn near there. We could probably get away with this. I'm going to make one more pass, clean it up, and then we'll keep going here. You got to make sure you stay out of the chuck. So reach over the top. while I'm doing this, I'm looking at the tan to blue line up against the back wall, and I'm fairing this curve because a fair curve beats the heck out of a drawn curve every day. Ask the shipbuilding guys. So even though I'm close, I'm pretty damn close. I'm going to tell you what, I'm going to call that done because I don't want to take the ends down anymore. So let me get some crocus cloth and we'll sand this. I want a long piece of this stuff. I had a couple of, oh, here we go. This will work. When you're sanding wood, you got to remember to polish the finish, not polish the wood. So here, I've still got a lot of lines going through this from what is arguably a very sharp rasp. That's pretty close. I'm going to get another piece of, I'm going to sand it one more time. Time to sand it is now, because once we cut the grooves in it, it's going to be very difficult to sand. That looks pretty damn good. Oh, it's got some finger grooves in this thing. Okay, it's 6.5 from end to end. And this thing is more than 6.5 inches long because the ends haven't really been trimmed yet because I haven't got them up on a forend. So what I do know is that I want to be somewhere in the middle of this. So I'm a little too far this way. I want to be over and spread my spread it out here. So I know I'm reaching in front of you, but I'm going to bring this back. The way this works is this gear is clutched in. So you can see as I'm turning this, the apron is moving, right? But you'll also see that from the direction that it's moving this way until it moves that way, there's quite a lot of dead space. So we got to remember that. We're going to get in the middle here. We're going to get roughly, we're going to split the difference between what we have and what we want to have, because we know that we're going to trim this. Right, there's the middle. And I want to be turning this lead screw this way because we're going to go that way. So, as we reviewed the last time, it's 120 degrees per rotation of this lead screw. So to go 375 thousandths of an inch, which is 3/8, we're going to make our cut, come out, go 1, 2, 3, and 15 degrees, and make another cut. And we'll see if we can do this in a slightly expeditious manner. Here we go. So now we want to move. We go 1, 2, 3, and then we come over and we look, okay, we say we're at 5 right there. So there's 5, and then there's another 10. So that's 120, 240, 360, and 15 is 375, which is 3/8 of an inch. And then we can plunge in and make another cut. Etc., ad infinitum, ad nauseum. Okay, hang on. It's always time for a good smoke in the morning. All right, here we are. Remember our template? Our template fits right on there. We got what we wanted out of the lathe. We've got a walnut fore end that now fits. This is torqued down, that's torqued down, and this is tight. So we made our replacement part for that Marlin Model 30G. There's a little bit more fitting to go, but if you're really not into this, and I mean, if you don't understand what it was I did here, I wouldn't be trying it. This is not something that you would want to do in the beginner mode. We had to break the fore end on the gun in order to get it apart. Now, these remaining pieces told us that certain things, it's about that long, that the finger grooves are about 375 apart, and I mean about, because I've got these spaced and they're spaced, and that's not done that way. We made our mistakes in pine. We made our mistakes in something soft. We built the jigs we needed to do in order to do it. Are there faster, higher speed, lower drag ways of doing this? Probably. If I had to make 100 of these, what I just did is a disaster. But we only had to make one, and when we're all done exerting all of this effort, we've got a Marlin Model 30G. It is what it is. Guys, we're getting into an era here where we're going to be making parts for Remingtons. We're going to be making parts for Winchester shotguns. It's absurd, but we're getting there. So sharpen up your stuff, pick up a tool, and start screwing up. And I'll see you guys down the gunsmith and rabbit hole at a later date also. It's been a pleasure.